Good afternoon, everyone, from my side. Again, thank you for the invitation. It's always a pleasure to show you what's possible in the sustainable construction. So the title of my presentation is, well, it should be an answer like, can we scale sustainable construction? And one of the messages I hope you will take home with you is that yes, we can do it by combining mass timber and prefabrication. So we are all here, I guess, because we know that we have a problem. And the problem is that we are emitting a lot of CO2. Can I point it out? I mean, it's pretty clear. Especially in the last 60 years, we increased the emission of CO2, of course, because the world is becoming a better place. People are living in a better standard of living, and it's all good. But we have this problem. And the CO2 is a gas. It stays in the atmosphere. And then the sun, the ray of the sun are trapped. And therefore, there is an increase of the temperature of our planet. We don't want that. Or at least we know that if the higher the average temperature goes, the worst thing happen. And again, we should avoid that. So right now we are at 1 average increase. We should at least stay around this data. And to avoid that, we need to change, of course. And I really like the Casper presentation where there is these 2 dogs and the owner is trying to pull them to the sea, because there are a lot of things that we need to change. And the world is going to the net zero target approach. What does it mean? That all these countries here are pledged. Finland is actually one of the first. They say by 2030, we are going to be net zero. And net zero means everything, not only construction. We are talking about construction here, but every aspect of our life. So the clock is ticking. We need to do something, and we need to do it fast. And parallel to this, it's true, maybe offices, we will need less offices in the future, but the number of people is increasing massively. And in 1950, we were at 2.5 billion. Right now, we are 8. And in 2080, probably we will be 10 billion. We need to house these people. We need to have offices for these people. We need schools for these people. And also, okay, maybe in other parts of the world, and they need they look at the Western society as a reference. That, I think, is also important. So what would be the natural strategy to house and build those new projects? Well, until now, we do multi-story timber buildings, and we have actually 4 ways to do that. Here I collected, I mean, maybe there is also steel, but let's keep it for 5. So we have concrete. Everybody knows how a concrete building is built. Then we also have prefabricated concrete. And there are some interesting examples out there. For smaller building, also low-rise building, we have timber frame. We have mass timber. I don't know how many of you heard, but it's pretty trend material right now. And last but not least, we have timber hybrid, so a combination of these materials. These are the 5 solutions that right now we have to tackle the construction problem. And this natural, obvious solution right now is to use concrete. We did it since probably 100 years. The supply chain is there. Everything is organized. But remember the first slide. We need to reduce CO2 emissions. And those 2 materials, concrete and steel, together are 8% of the yearly CO2 emissions of the construction sector. It's a fact, and we need to work around this. And Mother Nature gave us a gift. It's timber. It's a beautiful material. Finland is one of the great producers of it. And for many years before concrete, we used timber for our construction. And right now, we also are able to do multi-story timber buildings. They are popping out all over the world. That was part of my PhD, to study them, understand them. But what is important for you to understand is that you can ask yourself, okay, but why did we not build with timber 100 years ago, like structure like I showed you before? Well, it's important because usually, the usual process was this one. So you take a trunk, you cut it in 4 pieces, and so you have this regular shape. And then the carpenter or the framer would take it and then use it in the construction. Simple. It was good for small buildings, but it's a natural material. And engineers, especially in the modern times, they really like to calculate things, predict things. And with this natural material beauty, but you cannot really predict because maybe there are some knots inside or maybe there are some irregularities that you can't really understand. Therefore, taller buildings like this, not the most beautiful picture, but to just give you an idea that, no, this was not possible. What happened in the last 60 years, and glue laminated arrived 180 years ago, LVL 50 years ago, and CLT 20 years ago, is that actually we can cut the timber, glue it again, and understand how it's going to behave. And now engineers are very happy because, of course, they can calculate, they can use this material, and they already did it many times. This was part of my PhD. So if somebody asks you how many multi-story timber buildings there are completed in the world, the answer is more than 300. And this different color is more or less the countries. Most of them are in Western societies, let's say. So this was important, and I think it's a good answer for some situations. You can have load-bearing walls made of timber. You can have gigantic post and beam structures. This is an example in Norway. And what I found out is that at least there are 32 different ways to build a multi-story timber buildings. Actually, a lot of them are hybrid, and then I'm coming a little bit afterwards. But let's pretend that for the sake, it's okay like this. What's the problem? Remember, we need to find a solution, and we don't have time, to scale sustainable construction. All those buildings, or most of them, are prototypes. What does it mean? That a developer commissions an architect comes up with a project, then it commissions a structural engineer, which bases calculation on this specific project, and then they contacted the supply chain. And that was good, and it's necessary to do this, but if we want to scale, this is not the right approach. Why? Because you need to reinvent the details and the connection every time for every different project, or for most of it. So if you remember the 5 options, so let's look at together. So if I want to scale construction, what could I do? Well, from a time perspective, what gives me the quickest construction possible, especially now with high interest rates, that would be an advantage. Well, prefabrication is the right approach. Concrete buildings are very slow. Everybody, I think, are experienced with that. But they're cheap. The supply chain exists already, so of course they're cheaper. Some countries a little bit more than others. But the problem of mass timber is that it's a sustainable material, beautiful material, but it's expensive. Remember, some products are 20 years ago. So the supply chain is developed, but not as we want to scale, especially globally. And if we look at the quality of the buildings, well, timber wins hands-on. Because construction, especially with concrete, you need to repair, there are some uncertainties on the building side, and you need to change it. Prefabricated timber hybrid, in this case, wins especially well. But if we need to find a solution that is scalable today, remember, today, and I will show you the example of CREE, well, you need concrete, prefabricated concrete, or prefabricated timber concrete, because it uses a low amount of timber in this case. And last but not least, okay, we found 3 alternatives, but what about the CO2 emissions? Well, we say that concrete and prefab concrete are actually bad for the environment, so we need to find alternatives. So if you look at more or less the options that we have, this is the overall sum up, but we can remove timber frame. Why? Because it's not scalable for multi-story buildings. Yeah, you can do low-rise, but not for high-rise. We can remove concrete because it's, yes, it's cheap, but emits a lot of CO2, is imprecise, and the construction is very long. We can remove mass timber because, yes, it's sustainable, probably is the most sustainable material that we have, but it's not really scalable, and that's what we are searching for. So we are out with 2 options, prefabricated concrete or prefabricated timber hybrid. Well, there is one red here, and in our opinion, timber hybrid wins. But there is a problem, and it's the cost part, that we know that real estate developers ask us, okay, but I have two options, prefabricated timber hybrid and concrete. Why should I choose something that costs more? It's true, it costs more. But what the academia says, and also the practice, is that timber hybrid is perfect for construction quickly, high quality of the building, and also supply chain, but has high engineering costs. So it's a particular solution, and you need to rely on expert companies and people and stakeholders to manage such a building. And that's when CREE comes in. Because what we do is that we say, client, we already figure out all the details, all the standards. We reduce the engineering entry cost, but use a system, because it's a systemized approach. And what we did already 12 years ago is doing exactly that. So to search a solution that is timber-based, perfect for multi-story, good in prefabrication, and is resource efficient. What does it mean? I will show you some data, but we use the right amount of material, not too much, and not too much timber. And these help us to scale it and reduce the cost, which is important. And last but not least, we want also to have timber visible to the quality of the users that Casper said before. So the story, the journey of CREE is composed of three parts. You have 5 years where we develop our solution. Then we have a part where we master the CREE system by building our first reference. At the time, that was the tallest building in the world, timber building in the world. And then we master the solution by really operating as general contractor. So we build different typologies, assets, and in different locations. But after that, the success of our solution was as big enough that construction companies were asking us, okay, I understand your system. I can see it implemented in Singapore, in France, in Canada. Teach me how to do that. And that's why we changed our business model, and we actually become a consulting company. We are involved with any stakeholder on the project, no matter where we are located in the world, and we teach them or suggest them our solution in order to reduce the cost and scale it globally. This was a good idea because now we partner with construction companies all over the world, and we completed 20 buildings and 10 are under construction right now. Remember, if we need to find a solution that scales, CREE took 10 years to scale because now we are seeing an increase. The fear that I have as an expert in timber buildings is that, yes, we can develop a solution now, but time that it scales, we need 10 years. And Finland needs to be net zero in 2030. We don't have time. So now we operate, we operate in Asia and North America as well, but here you see the location. We are present in Europe, not yet in Slovakia. Maybe after this presentation we can find some partners. But overall, we are good in Germany, in Spain, all over these developed countries. And we partner with construction companies, as I say, from all over the world. These are the names of some of the partners that we have. We also partner with architects because we know that architects and engineers are really important early on in the concept of a building. And we also have companies that produce timber, for example, or services that integrates with our solution. The key aspect of CREE, the key message that we also share with our companies is that if you team up with us, you need to tell us everything you learn in these projects. So every CREE project has a new, maybe technical details, new innovations, and our role with CREE is to collect information and then share it with all our network. This is a true network effect, and so the learning curve of the entire collective is much higher. We meet also once a year and to discuss all those stuff. So what is the CREE system? You saw a picture before. It's a post and beam structure, load-bearing mass timber columns, connected with concrete timber prefabricated floor slab, in a nutshell. Here you see between 2.5 and 3 meters and 9 meters span. These are numbers that can change, but because we prefabricate the element from point A to construction, we need to transport them. And we compete with concrete, so we need to be as cheap as possible. And so what we figure out is that if we stay within this measurement, we can transport the element without special permissions, and this reduces the cost. Usually a CREE building is composed of a core made of concrete, but you can imagine also of different things. Our Japanese friends do it with steel. You have always the columns which are directly attached to the external facade. This is a key aspect when we assemble the buildings on site. Middle girders are made of steel or concrete, and then the floor slabs really close and seal the building. Here you see a picture from the building site. Is also prefabricated concrete if you want. And here is starts the key issue and transfer of knowledge that CREE does with companies. This is a picture from Portugal. Portuguese didn't have a lot of timber knowledge, and what we did is to transfer the know-how to develop such prefabricated timber elements and bring them on site like you see on the right. This is knowledge that is coming from Austria, it's pretty common in Germany and in Switzerland as well, and our job is to transfer these capabilities to any companies that wants to work with us already in the first project. The elements arrive on the building site, pretty prefabricated, but there are some degree of freedom and creativity with a CREE building. This is a free buildings with the same system, but they look completely different or a little bit different. We do the same for prefabricated timber concrete floor slabs. This is a picture from the off-site production facility that we can set up in any country in the world. We did it in Singapore, Canada, and Europe. And on the right, you see how the element is brought on the building site. We integrate also heating and cooling. For example, a new thing that we started in Germany is to put before heating and cooling pipes in the concrete layer, and then we pour concrete. And so we have a low-tech, and the moment the element arrives on the building site, is ready to go and to warm up or cool the building. What's the trade-off? Everything fine, everything nice, but if you are a developer, what do you need to do to achieve scalability and sustainability and cost competitiveness? Well, you need to involve us or companies like us early on, because we can tell our clients early on what could go wrong. We build up a digital twin, we quantify the material, and then we assemble the building pretty fast because we know the components. And this is a video of a 4,000 square meter building in Germany, completed 4 years ago. The client followed our suggestions and was assembled in 10 days with a crew of 6 people. That's another big challenge. We don't have the workforce on the building site. Well, here you need just 6 people. The core will assemble 2 weeks in advance, and then the process is always the same. You place the facade with the load-bearing columns, the middle girder, and the floor slabs, again and again and again. And especially the last floors, it gets really faster. What do you get? You get a building that after you seal the floor slab, it's water and airtight. And the interior after, in this case, 11 months is this. This is a typical size for any multi-story building in Europe, and we completed in 11 months. With timber, I don't know if I can show you, yeah. With timber present, yes, we use concrete, but timber is the protagonist on our buildings, and it brings quality also inside. So we built several buildings, more than 30. What I want to show you today is that we are really good in multi-story, in offices, educational buildings, hotel and student doors, because they're very repetitive. And what drives the cost of a CREE building is the floor slabs, because it's 70% of a building. And the more repeatable are the floor slabs, the lower is the cost per price unit. And so this is really good, especially in those assets, especially if they are more than 3,000 square meters, because you can repeat the floor slab as much as possible. I want to show you 3 projects just to give you an idea what's possible. This is under construction in Canada. This is for a university building. Interior is going to be pretty timber construction, and protagonist again is 30,000 square meters. And the story of this building is always the same. CREE, together with a local Canadian partner, search a local precast company that never did timber hybrid. We teach them how to do our solution. We also have a patent to do those stuff. And then here you see our Canadian friends that produce the elements. There are also some degree of freedom also to prepare in advance some pipes, connection, and so on. My technical department doesn't want me to show you these pictures, but just for your information, we can also do some specific parts. It's a little bit harder, but it's possible. And then you bring this element, usually 3 to 4, with a truck, possibly near the construction site. And this is the construction site. Core made of concrete already there. And here you see how, I don't know if 1, 2, and there is only one person that assemble the floor slab. They do it's pretty simple. A crane pick it up, keep it up, and then they position on the building site. This is our videos from, I think, 2 weeks ago. Here you see the CREE secret, let's say, the CREE connection is really what speed up and guarantee precision on the building site. And here you see that the floors are guided. They have holes in left and right. And through these holes, they guide the floor slabs on the column, which is timber. And then you seal the connections once the floor is in position. These are pictures from December. This is, again, we have a Pico delta beam in the middle. And these are pictures from now. In this case, we don't have the facade, which are right directly on the building site. We advise the client not to do that, but that's also their choice. You lose a little bit the advantage of CREE because timber stays a little bit exposed. And that's why you need to cover and you lose some erection time. But I'm pretty sure that after this project, they will change their mind for other projects. This is the final result. It should be ready by the end of this year. Another project which we complete in a completely different environment in Portugal, different climate, different companies. It's the first is for a chain of hotels called B&B, and after this they were happy enough to do other 3 buildings at least with us. It's composed of 2 buildings, again similar size of the video I show you, 4,000 square meters. One is hotel, one is a student dorm. And this, we took 8 days to assemble 1 block of these buildings. The story, again, always the same. Our partner in Portugal ordered timber from Spain. These are the beams that you see on the bottom right. And then they produce the floor slabs. They store it on their facility place safely. And then they brought them on the building site. Always the same solution. And that's companies that use our system because the details and the process are always the same. After 3 buildings, usually they don't need our support anymore, beside the sharing of additional details that other partners produce. So these are the facade element produced offsite by our partners. This is how the elements are brought on the building site. In this case, this is a facade. You see the load-bearing columns directly attached to the facade. And here, you see, I don't know, it's big enough, yes? 5 people. You need 5 people to assemble the facade. There is my colleague here that is just controlling everything is going well. And then that's the number of people, the highest number of people that you need. And so we know that the construction sector has also this challenge, and I think if prefabrication is also help. Prefabrication with concrete and timber, it's better than just concrete because timber is a light material. So transport and picture like these are possible because it's a light element. With concrete, it will be much harder. We also prefabricate the MEP. It's important. Usually companies that use our system not only prefabricate the structure, but also try to prefabricate as much as possible. And for example, the prefabricated bathroom. What's the result of all of this? This. This is a picture of the student dorms. This is what the modern generation asks us to deliver. They want a place that represents their values, which is timber, which is sustainability, which is quality of space. And this building costed as much as concrete. Why? Because we were involved early. We already organized the supply chain with our partner, and we deliver probably 6 months in advance. These are other pictures. And Jakob says before, reduce, reduce, reduce. That's how we reduce. This is how we scale sustainable construction. Because with CREE, the University of Porto proved that compared to a standard solution, we reduce of 50% concrete. It's not 100%. That's fair. But if we want to scale sustainable construction today, that's, in our opinion, the only way to do that. Reduce. Reduce steel, minus 41%. And reduce waste. A CREE building has 60% less waste on the building site. Think about the quality of the building site. Think about the safety of the sound. Usually, nobody really complain about what we do on the building site. And last but not least, of course, we reduce CO2 emission of 60%. Again, is it 100%? No. But if we want to scale sustainable construction, this is the tools that we have right now, and maybe in 10 years, we can improve the system even further. Last two projects. This is S6P Südkreuz. This is completed in Berlin. It's the most sustainable office building in Germany. The client didn't listen to us at the beginning. We say, you need to make decision early. They postponed some important decision, and the building costed more than conventional. That's true. But the building is such a unique building, typical CREE structure, left and right, load-bearing columns, middle girder in concrete and timber, that the final result was such a unique building, unique asset, that they sold it with a premium. And the tenant, a Swedish company, in less than 1 week, rented the entire space. They keep, of course, most of the office for them. But this is what the market asks already right now. And it's not so easy to deliver such quality and sustainable buildings. This is the typical work environment. Maybe that's what the public company in Finland would like, timber exposed. And to conclude, I have 2 minutes. To conclude, what's coming next? So I told you that we are good in multi-story, we are good in office, but we know that the demand of, especially in the coming years, is also residential. And we want to give tools to architects to play with our solution with already elements and stuff considered in advance. So we team up with a Danish architectural office called Effect. And together with other companies, we come up with a solution that is composed of a kit of parts. These are the parts. You have the floor slabs, typical of the CREE system. You have the prefabricated facade with the load-bearing columns. And then you have your partition walls. And then they also push the building even further. Let's think about the furniture. Let's think about the service appliances and so on. So really, let's give architects, and any architect in the world can use those systems, and let's play with this. And what we can do if we can imagine the building in this way. So we can compose it to have different volumes, different buildings. You have towers, you can do low-level buildings. You can have different type of facade. You can have also different type of units. You can think about maybe just a studio for one single student, or maybe a combination of various floor slabs and so on. Everything is already figured out. They need just to play with the Lego approach. And what I really liked that, yes, to lower the cost as much as possible, to make it accessible, Effect thought at the building in a different way. Let's grow the building together with the tenant. What does it mean? This is the picture when you buy the project, and this is maybe 5 years after when you change job and you increase your income, and this is when you also maybe get married or whenever you find a new partner. And so the flat lives and grow with you. And maybe this is a strategy to reduce cost at the beginning and then maybe increase the life of the building afterwards. What you obtain, this is an example of a livable place that is created just with a combination of a system, but it gives freedom. And for example, you have various type of facade that is possible. It's pretty flexible, and it's going to be implemented for the first time in a 65,000 development in the Netherlands, in Groningen. And Effect is working actively on that. So CREE, if it does something, it does it very big. But what I want to show you today is that scalable is possible. We should not use utopian ideas, but we should really focus on what we have. So we have a supply chain of concrete. Let's add timber. But let's see the building in a different way. And I'm not a fan of comparing always the car industry with the construction. I know it's different. But what I like to change the idea of our clients is that, yes, a car is successful because have a standardized assembly, always the same process, of different components, right? To be as successful as that industry and increase productivity, we need to think the building in a similar way, but assemble a building in a unique way, but with standard components, this floor slab, the facade, and so on. And in doing this, you can still have freedom, and we think that if the goal is to scale sustainable construction, that's the right way to approach it. Thank you for your attention. I don't even try to say these words, but we really think that together we can really scale and improve the built environment. This is my LinkedIn profile if you want to connect. Thank you everyone for attention. It was perfect.